Okay, this is how to convert a decimal. So if I give you something like this and I say I would like you to change this into a fraction, okay? Being able to read decimals here is crucial, okay? So here I have 0.775, but if you read it the correct way, it is really 775 thousandths. 775 thousandths. Okay? So you've got to be able to write it as a fraction. That's step one, and that's really just being able to read decimals correctly. Remember that you want to look at that last spot where that 5 is, and it's in the thousandths spot, so that's what your bottom denominator is. Now, obviously, with many of these, they will not be in lowest terms. So you've got to find the GCF, greatest common factor, of 775 and 1,000. So I want to take a minute here and show you how we do that. So we have 75 and 1,000. Now, first of all, with my 1,000, I'd like you to kind of notice a pattern here. I'm going to do it to 110. If I look at the prime factorization of 10, it's 5 and 2. If I look at the prime factorization of 100, it's 2, 2, 5, and 5. See what we're doing? We're adding another 5 and another 2 to each one. So this one would be 100 times 10. It's 5 times 2. And 100 is 10 times 10. This is 5 times 2. And 5 times 2. Okay? The prime factorization for 10 is 2 times 5. The prime factorization for 100 is 2 times 2 times 5 times 5. The prime factorization for 1,000 would be 2 times 2 times 2 times 5 times 5 times 5. Each time, if you notice, with our prime factorizations, look closely. We started at 10, we had 2 and 5. 100 went to 2 times 2 times 5 times 5. And 1,000 went to 2 times 2 times 2 times 5 times 5 times 5. We just added another 2 and another 5 for each 0 that we added. I would definitely recommend memorizing this pattern because it'll save you from making out all of these factor trees. Okay, you can just memorize the prime factorizations for 10, 100, and 1,000. Okay, and I can tell you right now that 10,000 would be equal to 4 2's and 4 5's. 2, 3. Okay? Right there, sorry, that's really hard to read, I apologize. That would be the prime factorization of 10,000. Just adding the extra 2 and the extra 5. For 75 here, I know 5 is divisible by it. 5 times 7 once, 5. Okay, 15 times 5. Erase that. Okay, 5 is prime. 15 can be broken apart to 3 and 5. Okay, so for our prime factorization here, we want to reduce 75 over 1,000. 75 is equal to, we have 3 times 5 times 5. And for 1,000, we have 3 2's, 2 times 2 times 2, times 3 5's. 5 is 5 times 5. Remember to cross off the pairs. So we don't have any 3s. We have a 5, another 5, and that's all. So the GCF, or I'm sorry, not the GCF, but the reduction of this, if you wanted to reduce it, would be 3 over, let's see, it would be 2 times 2 is 4, times 2 is 8, times 5 is 40. 3 over 40. So when you reduce everything, it is 3 over 40. And I just used the prime factorization method there to show that. And so if I skip a few pages, back to this, 340 was after we did all that work to find the fraction in lowest terms. Keep in mind, guys, that this right here is not in lowest terms. You must simplify to find your final answer. So just a real quick review. If I look at these, forget about this part. Look down here, right? Each decimal is a fraction. You first have to read the decimal. This would be, the 8 is in the thousandths, so this would be 168 over 1,000. 332, the 2 is in the thousandths, so this would be 332 over 1,000. And this one right here, 0.192, the 2 is in the thousandths, so it would be 192 over 1,000. Keep in mind, every single one of these need to be reduced. I'm not going to go through that again, but they need to be. If you had 0.52, that would be equal to 52 over 100 because the 2 is in the hundredths spot. If you had 0.8, that would be equal to 8 tenths. The 8 is in the tenths spot. Okay, so reading decimals is definitely key.